Yeah. Hola here, right? Can I start? No one want to talk and all because I know it's final round, right? See, exam is tomorrow. Hope you finished and all. But I want to just make you sure that you just covered some key points from electrochemistry. Sure, we can't finish within 1 hour electrochemistry, but I'll do maximum how much we can. We are planning to do two sessions, which is one is biomolecule and one will be electrochemistry. Within 1 hour, we'll do electro. Remaining 1 hour will go with biomolecule, right? So let's see some expected, some important areas of electrochemistry first. Then we can switch into biomolecule. Can I start now? Can you give me some response because I know since some glitching is there. Now it's okay, right? Everything is fine, right? Those who are here, please, my voice, video, everything is clear, right? Can I start? Any one of you, please, give me some thumbs up, anything, please. Those who are here, please respond in the way you can, please. We can start, right? Okay. Yeah, sure. So I'm starting. The chapter is called, yeah, sure. Yes, fine. Now it's okay. Starting electrochemistry. Electrochemistry, it's a branch of chemistry that deals with chemical energy to electrical energy, or you can say electrical energy to chemical energy, right? Anyway, I can give the key points of this chapter first of all, which includes electrochemical cell part, mainly starting from what is electrochemical cell, representation of electrochemical cell potential, then SHE called standard hydrogen electrode or measurement of electrode potential. Then we'll be switching into Nernst equation, relationship between delta G and E0 cell and Kc relation. That's all regarding the first part. Switching into electrolytic cell, having resistance, conductance, resistivity, conductivity, molar conductivity. Then we'll be entering into the Cauchy-Rash's law part. Cauchy-Rash's law, its application. Then the Faraday's first law, second law, numerical, ending with commercial cells, which includes primary cell, secondary cell, and we can have the final fuel cell too, right? Starting from electrochemical cell. So electrochemistry, starting from electrochemistry, we can go with electrochemical cell part. Electrochemistry, it's a branch of chemistry, deals with electrical to chemical or from chemical to electrical, okay, starting from electrochemical cell part. What is electrochemical cell means? It's a cell which can convert chemical energy to electrical. Ulta, electrochemical cell means it's a cell which will be converting chemical energy to electrical, or I can say the output of electrochemical cell will be electrical energy, or you can say electricity. Okay, this electrochemical cell may also called as galvanic cell or maybe like voltaic cell, all are same. Best example for electrochemical cell or voltaic cell or galvanic cell is Daniell cell. Daniell cell is a zinc copper cell. Best example for electrochemical cell is Daniell cell. Daniell cell is a zinc copper cell. Zinc dipped in zinc sulfate solution. Zinc dipped in zinc sulfate solution. Copper dipped in copper sulfate solution, which is connected through a voltmeter and a salt bridge, right? Setup of electrochemical cell will be, example say electrochemical cell is a cell which converts chemical to electrical. So output of electrochemical cell is electrical energy, may also called as galvanic cell, voltaic cell. Best example is Daniell cell. Daniell cell is a zinc copper cell. Daniell cell is a zinc copper cell. Zinc dipped in zinc sulfate solution. Copper dipped in copper sulfate solution, which is connected by using a voltmeter and a salt bridge. Which is connected by using a voltmeter and a salt bridge. A salt bridge is a U-shaped tube filled with inert electrolytes called KCl, KNO3, etc. Why we are using KCl and KNO3 in that U-tube, that salt bridge? Because KCl and KNO3 have equal mobility for cation and anion. I'm discussing about my Daniell cell. It's a zinc copper cell, zinc dipped in zinc sulfate solution, copper dipped in copper sulfate solution, which is connected by using a voltmeter and a salt bridge. Here zinc will be acting as anode, copper will be acting as cathode. Anode is a place at which here zinc will be acting as anode. Anode is a place at which oxidation happen. Oxidation means removal of electrons. So zinc will be removing 2 electrons to become Zn2+. Here copper will be acting as cathode. Cathode is a place at which reduction happen. Reduction means addition of electrons. So Cu2 plus will be added with 2 electron to become Cu. While writing overall reaction, yes, while writing the overall reaction, we can say 2 electron get cancelled. Remaining will be Zn plus Cu2 plus giving Zn2 plus Cu. Okay. So why we are using salt bridge, or what is meant by salt bridge means it's a U-shaped tube which is filled with inert electrolytes called KCl, KNO3. Why we are using KClO3, KNO3? Because they have equal mobility for cation and anion. Anyway, the functions of salt bridge will be completing the electrical circuit and will be maintaining the electrical neutrality. Expectation number one, what is the functions of salt bridge? Salt bridge is a U-shaped tube connecting two cells which is filled with inert electrolytes called KCl, KNO3. Why? Because KCl and KNO3 contains equal mobility or same mobility for cation and anion. What's the functions of salt bridge means? I can say completing the electrical circuit or to maintain the electrical neutrality. Here, zinc is acting as anode. Anode is a place at which oxidation happen. Oxidation means removal of electron. And copper is acting as cathode. Cathode is a place at which reduction happen. Reduction means addition of electrons. So I can say here electrons are moving from anode to cathode. Here you can say electron flow is from anode to cathode. If electron is moving from anode to cathode, conventional direction of electric current will be opposite to that of electron flow. If electron is moving from anode to cathode means I can say current will be moving from cathode to anode. Current will be moving from cathode to anode. In order to flow the current, there should be difference in potential, and current will be flowing from higher potential to lower potential. Since current is moving from cathode to anode means I can say cathode will be having higher potential which is called as positive, and anode will be having lower potential called negative. That means in electrochemical cell, cathode is positive, anode is negative. Representation of an electrochemical cell will be initially write the name of anode, put a bar, write anodic solution where anode is dipped, double bar, cathodic solution, double bar, cathodic solution, bar, cathode, bar, cathode. Example you can say in case of Daniel cell, zinc is the anode, so Zn bar. Anodic solution is ZnSO4, or you can say Zn2 plus, it's fine. Either you can say ZnSO4 solution or you can say simply Zn2 plus. Double bar cathodic solution is Cu2 plus, or you can say CuSO4, that which cathode is dipped one, bar Cu. Hope you are fine. So basics of electrochemical cell is a cell which converts chemical energy to electrical energy, may also called as galvanic cell, voltaic cell. Best example is Daniel cell. Daniel cell is a zinc copper cell. Zinc dipped in zinc sulfate solution, copper dipped in copper sulfate solution, connected through a voltmeter and a salt bridge. Salt bridge is a U-shaped tube connecting two solution which is filled with inert electrolytes called KCl, KNO3. Why? Because KCl and KNO3 have equal mobility for cations and anion. Functions of salt bridge will to complete the electrical circuit where electrons can flow, and one more I can say it will be maintaining electrical neutrality. Here zinc is acting as anode. Anode is a place at which oxidation happen. Oxidation means removal of electrons. So zinc will undergo oxidation to become Zn2 plus 2 electron. Copper is acting as cathode. Cathode is a place at which reduction happen. Reduction means addition of electrons. So Cu2 plus will be adding 2 electron to become Cu. While writing overall reaction, 2 electron get cancelled. Remaining will be Zn plus Cu2 plus giving Zn2 plus Cu. Here anode is a place at which oxidation happen, means anode is removing electron. Cathode is a place at which reduction happen, means cathode is accepting electron. That means I can say electron is moving from anode to cathode. Since electron is moving from anode to cathode, current will be moving from cathode to anode, because conventional direction of electric current will be opposite that of electron flow. If electron is moving from anode to cathode, means I can say current will be moving from cathode to anode. In order to flow the current, there should be difference in potential, and current will be flowing from higher potential to lower potential. Means I can say here cathode will be higher potential called positive, and anode will be lower potential called negative. The potential difference is called cell potential. The voltage difference is called the cell potential, given by the formula E cell equal to. The word meaning of E means potential. So E cell means cell potential, given by the formula E cell equal to E cathode minus E anode. E cell equal to E cathode minus E anode. E means potential. E cell means cell potential. E0 cell means standard cell. We say the word standard if the dipped solution or dipped setup is in a standard condition. Standard condition means 1 atm pressure, 298 Kelvin temperature, and the dipped solution should have a concentration of 1 molar. That's called standard condition. E is called potential, E cell called cell potential, E0 cell is called standard cell potential, given by the formula E0 cell is equal to E0 cathode minus E0 anode. Hope it is fine. Representation of a cell will be Zn bar Zn2 plus double bar Cu2 plus bar Cu. Hope it is fine. Now here an example we can say in case of Daniel cell, anode is zinc, so Zn bar anodic solution is Zn2 plus, and cathodic solution is Cu2 plus bar Cu. Can I go ahead? Hope you are here. Yes, tell me some yes please. Fine. Limited time. More we have to go. It's 10:17 right now. Oh, 50 minutes over. Yes. Tell me something, please. Dia, Rahman, Nabil. Here, right? Okay, I'm continuing. Question number 1, please. What is the necessity to use salt bridge in an electrochemical cell? Salt bridge is a U-shaped tube filled with inert electrolytes called KCl and KNO because they contain equal mobility for cation, anion. Okay? Yes, Christopher. Second one, my question, what is necessity to use salt bridge? Necessity means salt bridge will be connect, or you can say to complete the electrical circuit or to maintain the electrical neutrality. So the functions of a salt bridge or necessity to use a salt bridge, you can say to complete the electrical circuit, or to maintain the electrical neutrality. To complete the electrical circuit, to maintain the electrical neutrality. If salt bridge is removed, what happened if salt bridge is removed? Like it was like this. What happened if salt bridge is removed? If salt bridge is removed, potential drops to 0, current stops flowing. What happens if salt bridge is removed? Your answer should be like this. If salt bridge is removed, potential drops to 0, current stops flowing. Anyway, here my question functions are to complete the electrical circuit and to maintain the electrical neutrality. To maintain the electrical neutrality, please. Question number 2, please. Define electrochemical. That's okay, right? Electrochemical cell is a cell which converts chemical to electrical energy, also called as galvanic cell. Voltaic example is Daniel cell, zinc copper cell, anode is zinc. We find it, draw it and make it perfect. Okay. Then second part was in what happens if external potential applied is greater than E0 cell of electrochemical cell. If external potential applied is greater than E0 cell of electrochemicals, electrochemical cell will become electrolytic cell. Direction of flow of current will be reverses. If external potential applied is greater than standard cell potential of electrochemical cell will become electrolytic cell. Electrochemical cell will become electrolytic cell. Direction of flow of current will be reverses. Okay, that's all. So it's fine, right? What happens if external potential applied is greater than E0 cell means I can say electrochemical cell will become electrolytic cell. Direction of flow of current reverses. Now, given that standard electrode potential E0 of metals are given the correct order of reducing power. Let's see. Question, given that standard electrode potential E0 of metals are given here, potassium minus 2.93, silver it is actually plus 0.80, and chromium minus 0.74, iron minus 0.4, the correct order of reduction. What is meant by electrode potential? What is meant by electrode potential? The word meaning of potential means tendency. Electrode potential means tendency of electrode to undergo either oxidation or, that's why electrode potential is of two category called oxidation potential and reduction potential. Potential means tendency, voltage. That potential of electrode to get either oxidized or reduced is called electrode potential. So again say electrode potential can be defined in two ways called reduction potential and oxidation potential. That's why electrode potential can be expressed in two ways called oxidation potential and reduction potential. The word meaning of potential means tendency, children. So oxidation potential means tendency to undergo oxidation. Reduction potential means tendency to undergo reduction. If oxidation potential is high, if tendency to undergo oxidation is high, they will easily undergo oxidation. If reduction potential is high or tendency to undergo reduction is high, they will easily undergo reduction. Simple example. Suppose if you want to do more tendency for something, you will do that thing. Suppose if you want to eat biryani, if you have high tendency to eat biryani, you will eat biryani, right? That's I can say if high tendency to undergo oxidation, they will easily undergo oxidation. If there is high tendency for reduction, means they will easily undergo reduction. But remember, oxidation means removal of electron, reduction means addition of electron. If oxidation potential is high, reduction potential will be low. Ulta. Either donate or accept, both will not have. Either eat or not eat, right? Other we can say either removal or addition of electron, both will not happen. Hope it is clear. So before entering to my question, what is meant by electrode potential? Potential means tendency of an electrode to undergo either oxidation or reduction. Oxidation potential means tendency to undergo oxidation. Reduction potential tendency to undergo reduction. If oxidation potential is high, if tendency to undergo oxidation is high, they will easily undergo oxidation. If reduction potential is high, if tendency to undergo reduction is high, they will easily undergo reduction. But remember, if oxidation potential is high, reduction potential will be what? Low, because oxidation means removal of electron, reduction means addition of electron. If it is high tendency, donate, tendency to accept will be what? Like simple logic, right? As per IUPAC standard, simply electrode potential means it is reduction potential. As per IUPAC standard, simply electrode potential means it will be called what? Reduction potential itself. Hope it is fine. Clear? So now I come to my question. Given that standard electrode potential E0 of metals are the correct order of reducing power. So reducing power means what? Reducing agent, reducing power, reducing ability, they all are same. Reducing power, reducing capability, or reducing ability or reducing agent, all are same. What is meant by reducing agent? What is meant by reducing agent? Reducing agent means the one which undergoes oxidation will be called what? Reducing agent. Reducing agent will undergo oxidation. In order to undergo oxidation, I can say oxidation potential should be high, oxidation potential should be high, or you can say reduction potential should be what? Low. Because if oxidation potential is high, if there is high tendency to undergo oxidation, reduction potential will be what? Low. So oxidation potential should be high, or you can say reduction potential should be low. Reduction potential should be low. As per IUPAC standard, given potentials are what? Or given electrode potential will be same as what? Reduction potential. So from the given value, the one which having lower reduction potential will be easily undergoes what? Or will be having high tendency to undergo oxidation. They will easily undergo oxidation. The one which undergoes oxidation will be called reducing agent. The ability to act as reducing agent is called reducing power. Some metals are given. We have to arrange them in the increasing order of reducing power. I told you the given values are electrode potential can be expressed in two ways called oxidation potential and reduction potential. Potential means tendency. If oxidation potential is high, tendency to undergo oxidation is high, reduction potential will be low because it is ulta phenomenon, right? But as per IUPAC standard, simply electrode potential is what? Reduction potential. So I can say here, what we need to do is arrange them in the increasing order of reducing power. Reducing power means reducing ability, means reducing agent, all are same, undergoes oxidation. In order to undergo oxidation, oxidation potential should be high, or I can say reduction potential should be low. That means given values are what? As per IUPAC, electrode potential will be same as for reduction, or for shortcut. Reducing agent means the one which is having less electrode potential. Fine. The one which is having less electrode potential will be acting, will be coming MCQ, right? So I can say from the given values, the lowest value for potassium, that is minus 2.93. Then after minus 2.93 will come minus 0.74 chromium will come, minus 0.74 chromium will come. After chromium, minus 0.44 iron will come. And finally, who will come? The last one will be silver, having plus 0.8, right? So here you can say potassium is having least reduction potential. Least electrode potential means least reduction potential. If reduction potential is low, oxidation potential will be high, so they will easily undergoes oxidation. The one which undergoes oxidation will be called as what? Reducing agent. Ability to act as reducing agent is called reducing power. Okay, so go with option, which one? Ag, iron, chromium, potassium means C is the right answer. Hope it is fine. Are you okay? First, Muhammad, Hiba, Christopher, Dia, Rahman. Can I continue? Give me some energy. I know you are busy with preparations and all. Give me some energy, please. Here, right? Muhammad, Dia, Christopher. Can I continue? Sure. Things are clear until here, right? Okay, fine. Next one. Calculate the EMF of the following cell. EMF of the following cell is called E cell. Okay. EMF of the EMF of the following cell is called E cell. My expectation, there will be asking either the similar one, or you can say same, or maybe the similar one will be coming for 3 mark in section C. Now down, either they will ask directly the reaction 2Cr plus 3Fe2 plus giving 2Cr3 plus per 3Fe, or may expect like similar one in terms of zinc and hydrogen, or copper hydrogen, or copper cell, but I take it in terms of chromium. Let's try chromium and iron. So what we need to find out is, children, calculate EMF of the following cell. Okay, the reaction given to be 2Cr, which is a solid, plus 3Fe2 plus whose concentration within the bracket given to be 0.1 molar, giving what? 2Cr3 plus within the bracket the concentration given to be 0.01 molar, finally 3Fe, which is given to be a solid. Apply. What we required is EMF of the cell, that means E cell. Apply the formula. E cell equal to E0 cell minus 0.059 by n, either similar or the same. Okay, so E cell equal to E0 cell minus 0.059 by n log concentration of product divided by concentration of reactant. Apply the same ditto formula for all question. So what we required is E cell. How will you find out E0 cell? E0 cell will be given by the formula E0 cell is equal to E0 cathode minus E0 anode. If two potentials are given, higher value will be cathode, lower value will be anode. Enough. If two values are given, higher value will be cathode and lower value will be anode. So here I can say out of minus 0.74 and minus 0.44, higher value is minus 0.4. Higher value will be cathode, so minus 0.4. Minus lower value will be anode, lower value is minus 0.74. So we'll be getting what? Minus 0.44, minus will become plus 0.74, minus 0.44 plus 0.74. On solving, you will get answer 0.3 volt. That's the value of E0 cell. Apply over here. E cell equal to E0 cell is 0.3. Minus 0.059 by n. What is n? N is the actual number of electron cancelling, is, we can say in the reaction, change in state is n. In the reaction, you can say change in state is n. For example, here state of chromium is 0. Here state of chromium is 3. So 0 to 3 means change is 3. That's for 1 chromium, but here contain 2 chromium. So total change will be 3 into 2 called 6. For 1 chromium, change is 0 to 3 called 3, but here we have 2 chromium, so total change will be 6. So 0.059 by 6 into log of concentration of product by concentration of reactant. Products are 2 Cr3 plus, that coefficient will be coming like power, so Cr3 plus raised to 2. Here Fe is a solid. For solid, concentration will be 1 into 1 means no need to take, divided by concentration of reactant. Who is reactant here? Chromium, it's a solid. For solid, concentration will be 1. Yes, it will be 1. So leave about that. 3 Fe2 plus will be coming as what? Fe2 plus raised to 3. Dump the values over here. You will get like 0.3 minus 0.059 by 6 log of, how much is concentration of Cr3 plus? It is 0.01, same as 10 raised to minus 2, right? 0.01, same as 10 raised to minus 2. So 10 raised to minus 2 the whole cube divided by concentration of Fe2 plus is 0.1, same as 10 raised to minus 1. That coefficient will be coming like a power. So we'll get what, please? 0.3 minus 0.059 by 6 log of, how much is 10 raised to minus 2 the whole cube? 10 raised to minus 2, it is 10 raised to minus 2, right? It's actually 10 raised to minus 2 the whole square, right? By mistake, I guess. Yeah. It is, coefficient is 2 Cr3 plus, will be coming like Cr3 plus raised to 2. So 10 raised to minus 2 whole raised to 2, because coefficient is 2, 2 will be coming as power. So we'll be getting like 10 raised to minus 2 the whole square is 10 raised to minus 4 divided by 10 raised to minus 1 the whole cube is 10 raised to minus 3. Solving, what we'll get, please? 0.3 minus 0.059 by 6 log of, how much is 10 raised to minus 4 by 10 raised to minus 3? 10 raised to minus 4 minus 3 minus 4 plus 3, 10 raised to minus 1, right? It is 10 raised to minus 1. So it will be like 0.3 minus 0.059 by 6. Log 10 raised to minus 1 will be minus 1 into log 10. Log 10 is 1, so minus 1 into 1 is minus 1, right? Log 10 raised to minus 1 will be minus 1 log 10, minus 1 into 1 is minus 1. This minus will become plus, so answer will be 0.3 plus 0.059 by 6. So on solving, you will get the answer. Remember, unit is must compulsory. Unit of E0 is or E cell is volt. Hope it is fine. Solve it, you will get the answer. Can I continue? Faiz, Dia, Naomi, Hiba, Christopher. I hope the first part is okay. I mean, the question is fine. Either the same one in section E or maybe the last question of your board exam, maybe this E cell question. I mean, Nernst equation based one. Apply the formula. E cell equal to, okay, Christopher, 0.309, sure. 0.309. You can get a question like this, either same one or apply the formula, dump the formula E cell equal to E0 cell minus 0.059 by N log product by reactant. This coefficient will be coming like power. Remember, solid come, it will be 1. Yes, sure. Next one, please. Delta G and E0 cell. Question. Delta G and E0 cell for a spontaneous reaction will be, a reaction will become spontaneous, that we covered in first year thermodynamics also, gives Helmholtz equation. A process will become spontaneous if delta G is negative. Then you know, example, what is spontaneous process? Which has a natural tendency to occur by themselves is called what? Spontaneous, like melting of ice, raining, evaporation, they all are called spontaneous process, happen by themselves. Anyway, as per Gibbs-Helmholtz equation, Gibbs energy equation, a process will become spontaneous if delta G is negative. So I can say a process will become spontaneous if delta G is negative. So to become spontaneous, delta G should be negative. So either C or D, B may come because both of them delta G is negative. What's the formula connecting delta G and E0 cell? You may get one more numerical either by using the formula delta G naught is equal to minus NF E0 cell, or there is one more numerical based on the formula E0 cell is equal to 0.059 by n log K. Expect one more numerical from this formula. Delta means change. Delta G means change in Gibbs energy. Delta G naught is called standard change in Gibbs energy given by the formula minus NF E0 cell. Delta means change. Delta G means change in Gibbs energy. It is given by the formula minus NF E cell, where N is the number of electrons involved. F is called 96500 coulomb. E cell is called cell potential. But I told you again, delta means change. Delta G means change in Gibbs energy. Delta G naught is called standard change in Gibbs energy. Make it standard. So it will be coming like minus NF E0 cell. Okay, expect either by using this first one or second one a numerical for your tomorrow's chemistry board exam. So here my question, to become spontaneous, I know as per Gibbs equation it should be delta G negative. Basil, delta G should be negative. It's okay, go with either option B or C, both are fine, but we have to go with the E0 cell also. See, delta G naught is given by the formula what? Minus NF E0 cell. N is always a positive quantity. F is always a positive quantity. To become delta G negative, to become spontaneous, delta G should be negative. To become delta G negative, I'm sure E0 value should be positive, because if this will become plus, plus into minus means delta G will become negative, or process will become spontaneous. Okay, so to become spontaneous, delta G should be negative. So B and C equally applicable. But what about E0 cell? Delta G naught is given by the formula minus NF E0 cell. N is a positive quantity, F is a positive quantity. To become delta G negative, I'm sure E0 cell should be what? Positive, because plus into minus will give negative. So you can say negative and positive. Go with option C. C is the right answer. Clear? Can I continue, please? Now, next one. Before the question, what is meant by conductivity? Conductivity is there, molar conductivity. Here my question is conductivity. What is conductivity? Conductivity is the conductance offered per unit volume. Conductivity is the conductance offered per unit volume. Imagine you have a solution. Imagine you have a solution filled with some electrolyte, whatever may be, KCl, whatever may be, having some electrolyte. Okay, what is meant by conductivity, please? Conductivity is the conductance offered per unit volume. Definition for conductivity is the conductance offered per unit volume. Okay, suppose here we have I'm calling it as a concentrated one. Imagine you have a concentrated solution. I am diluting it by adding water, okay, undergoing dilution. So we'll get a diluted solution. We'll be adding water, so we'll get a diluted one. Obviously, since we are adding water, space will be increasing, so it will be more spread over there. It's a diluted one, right? It's a diluted solution. My question for you, who will be having more conductivity? Who will be having more conductivity? Conductivity is the conductance offered per unit volume. If you take a unit volume in a concentrated solution, if you take a unit volume in a concentrated solution contain more number of ion. More number of ion means more mobility. More mobility means more conduction, because the word meaning of electricity means current means movement. Movement of electrons, movement of ions, movement of electrons, movement of ions. What? It's fine. So it is here we have two solutions called concentrated one and diluted one. Concentrated solution or dilute. My question for you, who will be having more conductivity? By definition, what is conductivity? Conductivity is the conductance offered per unit volume. Per unit volume. In a concentrated one, in a unit volume contain more number of ions, more mobility, more conduction. But in a diluted one, if you take a unit volume in a diluted solution, number of ions are less, so mobility is less. Number of ions less means what will be less? Conduction, because the word meaning of conduction of electricity means movement. Movement of electrons, movement of ions. So my key point is conductivity means it is a conductance per unit volume. On dilution, since ions are spread over there in a unity volume, number of ions will be less. Or I can say, a very important question, same associations may come, same words may come. My question for you, what is conductivity? Means conductance per unit volume. And what happens to conductivity on dilution? On dilution, I can say number of ions, or you can say on dilution space are increasing. So in a unity volume, number of ions will be less, or in a single word, I can say on dilution, conductivity decreases due to decrease in number of ions per unity volume. On dilution, conductivity decreases due to decrease in number of ions per unity volume. So if you take a concentrated one, in a unity volume, number of ions are more, but in a diluted one, in a unity volume, since spreading happen, number of ions unity volume is less. Come back to my question. Assertion: conductivity of electrolyte increases with the decrease in concentration. Actually, decrease in concentration means what? Increase in dilution. On dilution happening means what is happening? Or I can say concentration dilution is inversely proportional. So here given that conductivity of electrolyte increases with the decrease in concentration. Decrease in concentration same as what? Increase in dilution. So on increasing dilution, conductivity increase is wrong, because on dilution, conductivity decreases due to decrease in number of ions per unit volume. Means assertion will be wrong, because assertion given that conductivity of electrolyte increases with the decrease in concentration. Decrease in concentration same as increase in dilution. On increasing dilution, conductivity is not increasing, conductivity is decreasing because of decreasing number of ions per unit volume. Means yes, assertion is wrong. What about reason? Number of ions per unit volume, that is okay. That is okay, because on dilution, number of ions per unit volume decreasing. So we can say for this question, go with the option assertion is wrong and assertion is false and reason is true. Whatever the option C and D, go with that one. Yes, Christopher, sure. Hiba, yes. Can I continue? Yes or no, please? You're right. Sure, Christopher, Basila, Hiba, Dia, Basil. Okay. We can finish it fast. We can go for study, right? We'll finish it fast and go study back again. Okay. Now, my next expectation, my next expectation for the tomorrow's board is draw the relationship between molar conductivity and concentration for a strong and weak electrolyte. I'm going to plot a graph. The graph is going to be plotted between lambda m and root c. Okay, I'm going to plot a graph. The graph is plotted between lambda m and root c. What is lambda m? Called molar conductivity. Molar conductivity, both are different. Conductivity is okay for you. Conductivity is the conductance per unit volume. Okay, now it's different approach. It's molar conductivity. Don't get mistake, my children. When I evaluate my module 1, module 2 paper, majority of you made mistake in the concept of this one. Please don't mistake for tomorrow's board. Make it clear. Okay, so its conductivity is okay. Now going for molar conductivity. So it's a graph plotted between molar conductivity and root c. Y-axis contains molar conductivity, x-axis contains root c. C means concentration. C means concentration. I will be plotting this graph for both strong and weak electrolyte. What is meant by strong electrolyte means? Strong means they will get completely decomposed into ions, so there will be having more. They themselves can completely decompose into ions, so we'll be having more number of. An example, you can say HCl, HNO3, H2SO. They all are strong. They can completely decompose into ion. We'll be having more number of ions, so they themselves can produce more number of ions. Okay. What about weak electrolyte? They will get partially incompletely ionized. What is meant by weak electrolyte means they can partially or they will be incompletely electrolyte. Incompletely ionized or partially ionized. I'll give you the answer if these questions are now coming. Let's see. So a strong and weak electrolyte. One is strong and one is weak. So I'm going to plot a graph. The graph is going to be plotted between lambda m and root c. Lambda m is coming on y-axis called molar conductivity. X-axis contains root c called concentration. Okay. See, I'm going to plot the graph for both strong and what is meant by strong means they completely get ionized and will be having more number of ions. Weak means partially or incompletely ionized. Initially, I'm going to plot the graph for strong electrolyte. For a strong, I obtain a straight line graph. For a strong, I obtained a straight line. What is this straight line graph indicating? Or let's finish it both, right? We'll be getting a straight line for a strong electrolyte, and we'll be getting a parabola for a weak electrolyte. We'll be getting a parabola for a weak electrolyte. Let's analyze the graph. Okay. While analyzing the graph, I can say, y-axis contains molar conductivity. As we move from here to here, molar conductivity is increasing. As we move from here to here, molar conductivity is decreasing. As we move from here to here, concentration is increasing, or you can say what? Dilution is decreasing. Similarly, as we move from here to here, concentration is decreasing or dilution is increasing. It's a graph plotted between lambda m and root c. Root c means concentration. Okay, y-axis contains lambda m and x-axis contains root c. As we move from here to here, molar conductivity increasing. As we move from here to here, molar conductivity decreasing. As we move from here to here, concentration increasing or dilution is decreasing. As we move from here to here, concentration is decreasing or dilution is increasing. Let's analyze a strong graph. Okay, in this graph, as we move from here to here, as we move from here to here, concentration is decreasing or dilution is increasing. Correspondingly, graph is moving up, means I can say molar conductivity is also increasing. On analyzing the graph, I can say as we move from here to here, concentration is decreasing, dilution is increasing, correspondingly molar conductivity increasing. Okay, it's a straight line graph, so I can say gradual increase. Concentration decreasing, dilution increasing, molar conductivity increasing gradually. Okay, what about weak? Analyze a weak graph. In case of weak electrolyte, we can say, in case of weak, we can, and let's take 3 points, okay, 1, 2, 3. As we move from here to here, concentration is decreasing or dilution is increasing. Okay, here also molar conductivity increasing, but that increase is a sudden increase or a striking effect. Why? That means whether it is strong or weak. As we move from here to here, concentration decreases, dilution increases, correspondingly molar conductivity increases. Okay, but that increase is a gradual increase, step by step increase for strong, but that increase is a weak for, that increase is sudden or striking for weak. Why? In case of strong electrolyte, when you dilute the solution, obviously space is increasing, so mobility is increasing, so conduction. That's why on dilution of strong, as you add the water, space is increasing, mobility is increasing, conduction increases. Okay, but in case of weak, you are adding water, space is increasing, mobility is, but in addition to, because of that force of water, more ions will be generating in the case of weak. But strong means before adding itself, before addition of water, before dilution, they are completely get ion. There is no chance to increase number of ions. Because strong, they themselves get completely ionized. On addition of water, only space is increasing, only mobility is increasing. That's why conduction. But in case of weak, not only space, not only mobility, because of addition of water, some more ions are also generating. But in strong, only mobility. Why ions is not? Because in case of strong, before addition of water itself, they themselves get completely ionized before adding water. That's the difference between strong and weak in the variation of molar conductivity versus root of concentration for strong and weak. So strong means completely ionized, weak means partially ionized. In case of strong, the graph is a straight line. In case of a weak, the graph is a parabolic or a curved one. As we move from here to here, for both of them, concentration increases, concentration decreases, dilution increases, molar conductivity increases. Okay, but that increase is a gradual increase because there is only increase in mobility in case of strong. But in case of weak, not only mobility, but ions are also, because weak, they themselves cannot get complete because of force of water, more ions will be. But in case of strong, before addition of water itself, they get completely ionized. If you extrapolate the graph of strong, graph will meet on y-axis. If a graph meet on y-axis, x value will be 0, or I can say concentration will be 0, or dilution will be maximum. That molar conductivity at maximum dilution is called limiting molar conductivity, calling it as lambda m0. We are getting a straight line graph for strong electrolyte. If you extrapolate the graph, if you extended the graph will be meeting on y-axis. If a graph meet on y-axis, X value will be 0, concentration will be 0, dilution will be maximum. That molar conductivity at maximum dilution will be called limiting molar conductivity, may calling it as lambda m 0. So it's a straight line. So straight line is applicable for strong, but if you extend the weak one, it's a curve, it will meet at our infinity also. We cannot find out the lambda m 0 of a weak from the graph, but we can find out by using a law called as Kohlrausch's law. On strong, we are getting a straight line graph. For a weak, we are getting a parabola. If we extend the graph of strong, the graph will be meeting on y-axis. If a graph meet on y-axis, X value will be 0, concentration will be 0, or I can say dilution will be maximum. That molar conductivity at maximum dilution will be called lambda m 0, calling it as limiting molar conductivity. But for a weak, it's a parabola will meet at infinity only. That's it. Now my question was, what? Yeah, variation of ditto. The variation of molar conductivity dilution for two electrodes are given below. Identify the type of electrolyte. Give reason for the variation. What happens on extrapolation of lambda m to concentration approaching zeros for A and B? Upright. See, the graph is between lambda m and c raised to 1 by root c. Question, identify the molar conductivity with dilution of two electrolytes given below. Identify the type of electrolyte. The one which is giving straight line will be the strong electrolyte. The one which is giving the curve will be the weak one. Give the reason. You please give the reason. Okay, I'm not explaining again. We get one more question from here. It will be coming like this. We have two electrolytes A and B. On dilution, molar conductivity of A increases 25 times and that of B increases by 1.5 times. Who will be strong, who will be weak? Same question may coming like this. Suppose we have two electrolytes called A and B. On dilution, molar conductivity of A increases by 25 times and B will be 1.5. So 25 times is a sudden increase. So it's a weak one, it's a parabola. 1.5 time increase is a gradual one. So I can say it is a strong one. Question clear? We have two electrolytes called A and B. On dilution, molar conductivity of A increases by 25 times, that of B increases by 1.5 times. Yes, Muhammad, that 1.5 time is a gradual, it will be the strong, 25 time will be striking, will be weak. Okay, go ahead, please. Next one. Before next one, hope you know about the theory called Kohlrausch's law. What is meant by Kohlrausch's law? Question will be coming like this. What is Kohlrausch's law? Give its two applications. Question, what is meant by Kohlrausch's law? Give its two application. What is meant by Kohlrausch's law, please? What is meant by Kohlrausch's law? Kohlrausch's law means lambda m is called what? Molar conductivity. Lambda m 0 is called what? Limiting molar conductivity. As per Kohlrausch's law, limiting molar conductivity of electrolyte, lambda m 0 of electrolyte is equal to lambda m 0 of cation plus lambda m 0. Please write in words also. If a question comes, what is Kohlrausch's law? Explain its application, write in words also. Anyway, what is Kohlrausch's law means lambda m called molar conductivity, lambda m 0 called limiting molar conductivity of electrolyte is equal to lambda m 0 of cation plus lambda m 0 of anion. See, lambda m is what? Molar conductivity. Lambda m 0 means limiting molar conductivity or molar conductivity at infinite dilution of electrolyte is the sum of limiting molar conductivities of cation plus. An example, NaCl is an electrolyte having Na plus and Cl minus. As per Kohlrausch's law, lambda m 0 of electrolyte, which is NaCl, it's a sum of lambda m 0 of cation called Na plus and lambda m 0 of anion called Cl minus. Okay, go through it. Application number one. Application number one, we can find out the application number one, we can find out the lambda m 0 of a weak electrolyte by using Kohlrausch's law. We can find out the lambda m 0 of a weak electrolyte. Similarly, we can find out degree of dissociation called alpha, expecting one numerical by using degree of dissociation. Alpha is ready here, just wait. Okay, anyway, degree of dissociation. Application number two, we can can find out the degree of dissociation. Degree of dissociation is called alpha, given by the formula lambda m by lambda m 0, where lambda m is a molar conductivity. Lambda m 0 is called limiting molar conductivity. Lambda m is a molar conductivity. Lambda m 0 called limiting molar conductivity. Okay. Anyway, molar conductivity, lambda m is given by the formula 1000 into K by M, where K is the conductivity, M is the molarity. Okay. So concluding, what is called Rash's law? Lambda m is called molar conductivity. Lambda m 0 is called limiting molar conductivity as per Rash's law. Limiting molar conductivity of electrolyte is the sum of limiting molar conductivities of cation plus anion, means lambda m 0 of electrolyte is equal to lambda m 0 of cation plus lambda m 0 of anion. To application number 1, you can find out the lambda m 0 of a weak, because you know in the graph you can find out only lambda m 0 of strong because they will extend. It's fine, but here you can find out by using the law called Rash's law. Second one, we can find out degree of dissociation alpha, given by the formula alpha is equal to lambda m by lambda m 0. Lambda m is called molar conductivity. Lambda m 0 called limiting molar conductivity. Lambda m is given by the formula 1000 into K by M, where K is the conductivity, M is the molarity. Sure, Muhammad. General, one explain. That's the end of right, man. It's the end of right. General trend of towards less electronegative value. Go, man. E0 value less negative means what? It's negative. Give that one. Hydration and that with that relation, Muhammad. Go ahead. The end of right. Now, next one. Question. Conductivity means K. Conductivity of 2.5 into 10 raised to minus 4 molar methanoic acid. Methanoic acid is having formula HCOOH. Methanoic acid having formula HCOH is 5.25. So conductivity means K, kappa, given by the formula. Wait, so question, conductivity K of 2.5 into 10 raised to minus 4 molar methanoic acid is, so conductivity is given by K is equal to 5.25 into 10 raised to minus 5 Siemens centimeter inverse. Siemens centimeter inverse. Siemens centimeter inverse. Okay, so I don't think I will be able to finish. Let's see how much we can do it. Okay, so it's conductive question given that conductivity of 2.5 into 10 raised to minus 4 molar. That 2.5 into 10 raised to minus 4 is the molar. Conductivity K given to be 5.25 into 10 raised to minus 5 Siemens centimeter inverse. Calculate its molar conductivity. Molar conductivity means lambda m. And degree of dissociation means alpha. So what we need to find out is lambda m and alpha. Let's see. Repeating once again, conductivity, that means K of a 2.5 into 10 raised to minus 4 molar methanoic acid, formic acid formula HCOH is 5.25 into 10 raised to minus 5 Siemens centimeter inverse. Calculate the molar conductivity means lambda m, and degree of dissociation means alpha. Molar conductivity lambda m given by the formula, please, 1000 into K divided by M. Molar conductivity lambda m is given by the formula 1000 into K by M. 1000 into K, how much? K is given to be 5.25 into 10 raised to minus 5 divided by M. M is molarity, given to be 2.5 into 10 raised to minus 4. I guess on solving, answer will be 210. Please cross check. I'm not sure, but I guess 210. Lambda M is 210. Cross check. We get the finish, right? So it's like a lambda M is okay, 210. So lambda m part is unit of lambda m is important, Siemens centimeter square mole inverse. If you are losing this unit, half mark is gone. Please make sure that for first 3 chapters solution electrokinetics units are combined, otherwise half mark will be gone. So it is 210 Siemens centimeter square mole inverse. That part is okay. Then alpha, degree of dissociation alpha is given by the formula lambda m divided by lambda m naught. Okay, how much is lambda m, please? Given to be 2, obtained to be 210 divided by lambda m 0 divided by lambda m 0. How much is lambda m0? Just sum it, because instead of giving the lambda m0 of meth, they're given separate sum it. That's as per Coltrash's law. Since they're given the lambda m0 of HCOO minus and lambda m0 of, just sum that two values. So I can say total lambda m0 will be the sum of these one. It's, I guess, 349.5 plus 50.5. On solving, how much, please? On solving, how much? 349.5 plus 50.5. So it is 0, 1, 0. It's 400, right? 400, I guess. Yeah, 400. So 210 by 400 will be the value of alpha, unit of alpha unitless. Okay? It's already 11 o'clock. I'll take one more question for you. Reminding you can solve. I'll give the questions. Wait, okay. Come to the point. Yeah, Hiba 240 is okay. Right? Hiba. Leave it. Now going for the second one. It's actually coming in sample paper. Let's try. Question. The molar conductivity of CH3COH at infinite, that means lambda m0, right? Molar conductivity of CH3COH at infinite dilution means lambda m0, which is given to be how much? 390 Siemens centimeter square mole inverse. Question, using the graph and given information, the molar conductivity of CH3COK at infinite dilution will be. So what we need to find out is lambda m0 of CH3COOK. What we need to find out is lambda m0 of CH3COK. Given values are, these intrinsic values are called lambda m0. That meeting points are called lambda m0. So lambda m0 of KClOK, lambda m0 of HClOK. Given that lambda m0 of CH3COH is 390 Siemens centimeter square mole inverse, okay. And we have to find out lambda m0 of CH3COK. The meeting points are lambda m0. So I can say lambda m0 of HCl, the meeting point of HCl is lambda m0. That meeting point of HCl is how much, children? 425, okay, cool. What about lambda m0 of this KCl? It's coming between 125 and 175, means around 150, right? Coming around that, I think 25 is a gap, so you can go with 150. That's a lambda m0 of KCl. That's a value of lambda m0 of KCl, which is given to be 150, right? 150. So we have to create an equation for CH3COK. Create an equation for CH3COK by using CH3COH. HCl and case whose lambda m0 we know. Create an equation for CH3COK by using the values which we know, that's called CH3COH and HCl and KCl. So rearrange a formula. We'll get what, please? I'm adding CH3COOH and KCl, because from CH3COH we'll get CH3CO, but that is okay, safe. Then from KCl we'll be getting K, that's also okay, but I don't want HN, so subtract that HN. Put lambda m0 throughout. We'll get what? Lambda m0 of CH3COOK is equal to lambda m0 of CH3COH plus lambda m0 of KCl minus lambda m0 of HCl. What we need to find out is lambda m0 of CH3COK. Okay, given values are lambda m0 of CH3COH, HCl. Okay, so rearrange and create equation in terms of CH3COK. To get CH3COK, I will be adding CH3COH and KCl. Okay, from here we will get CH3CO part, we'll get K, so on adding you will get CH3COK. But I don't want HCl, so minus HCl. Put the values, please. CH3COH is 390. HCl value is 425, right? HCl value is 425. Then it's okay, right? Any mistake we have done over here? CH3COH is 390, okay. No, it's KCl, right? KCl value is 150, yes. KCl value is 150, right? Yeah, this point, Russell, this point is lambda m0 of KCl called 150. This is lambda m0 of HCl called 425. So for KCl, the value is how much? 150. So 150. So 150 minus for HCl, the value is how much? 425, right? On solving, I guess your answer will be 115. Please cross check. 390, 150. So 0, 4, 540 minus 425. So 5, 1, 1. Yes, 115. Yeah, I done that. Hiba, KCL is 150 minus. Now it's okay, right, Hiba? KCL value is 150 minus 425. Now the value is fine, right? Some more questions are there, but I'm not taking time of Ashin sir. You can go with this one. It's actually coming under Faraday's first law. What is Faraday's first law? Mass of a substance deposit electrode will be directly proportional to charge pass. Coming from Faraday's first law, mass of a substance deposit at electrode will be directly proportional to charge. It's called M proportional to Q, called Faraday's first law. Faraday's first law. Then you may get question like this. Which is the better, or which one which is used for watches and hear? The cell which is used in watches and hearing aid will be mercury cell, because mercury cell can keep constancy in potential. The cell which is used in hearing aids and watches will be mercury cell, which can keep constancy in potential. The one which used in Apollo space program is fuel cell, H2O2 fuel cell. The one which is used in inverters and automobiles are lead storage battery. Please go through it. Okay. Corrosion question is there. Then fuel cell. See, I'm damn sure you will be having 5 cell code: dry cell, mercury cell, lead storage cell, nickel cadmium. Out of these 5, one will be 100% section E question. Either write the anodic and cathodic of fuel cell, or may come lead storage cell, or may come dry cell. Nickel cadmium, rare chance. But when you just go with these 5 cell, mercury dry cell, mercury cell, lead storage cell, and nickel cadmium cell, and fuel cell. Which one used in watches and hearing aid is mercury cell. Mercury cell can keep constancy in potential. One used in Apollo space program is fuel cell. One which you use in automobile and inverter is what? That's called the lead storage cell. Okay, I'm concluding my session right now. We have started from the basics of electrochemistry part. Hope it is fine. Make sure that one question will be coming from the first part, mainly that electrode potential, inertial equation based thing, Faraday's first law. And this graph, as you know, in this graph, as we move from left to right, concentration is decreasing, dilution is increasing, molar conductivity is increasing. Okay, but that increase is a gradual for strong, but it's a parabolic for weak. Reason also go through it, please. We can intersect this point. If you extrapolate the graph will meet on y-axis. If a graph meet on y-axis, x value will be 0, concentration will be 0, dilution will be maximum, called that's called that molar conductivity at maximum dilution will be called limiting molar conductivity. Go through it, please. Then strong and weak. So if you are fine, we'll see later. You can start with biomolecule round. Okay, thank you, bye. Yeah, I'm going. I want to, Ashwin sir will finish the portion with you regarding this biomolecule portion. So I hope I'm wishing all the very best for tomorrow's exam. It will be very, very gonna nice for you. Remember, if exam gonna tough, don't get panic. It will be tough for entire people. Lakhs of people will be having tough. But I'm sure my kid will be having simple only. But anyway, sure, if exam got tough, don't get panic, get cool. Okay. So very, very all the best. We can have a meetup and all after your exams and all. So you can enjoy with Ashwin sir. Will be doing biomolecule right now. Bye. All the best. Very all the best. So do it well. Okay.
Hello. Good afternoon. Hello, hi. Who is here in this live? Hiba, Mohammed is there. Yes, hi all. Are you there? Yes. Tia, Raisal is there. Okay. Yes. Anyway, today we are going to discuss some questions from the topic biomolecules. And you know, biomolecule is one of the organic chemistry chapter that you can easily score. That is, the questions from biomolecules will be directly asked. So it will be very easy to score from biomolecules. So we can start biomolecules session. So the first question is, it is very simple question actually. You can see that the functional groups present in carbohydrate are. So what are carbohydrate? From the definition itself it is clear. You know what is the definition of carbohydrates? Carbohydrates are, yes, polyhydroxy aldehydes or ketones. Okay, carbohydrates are polyhydroxy aldehydes or ketones. Okay, so from the definition itself it is very much clear that polyhydroxy. What do you mean by polyhydroxy? Do you know the structure of glucose and do you know the structure of fructose? From the structure of glucose and fructose, it is very much clear that it will contain, yes, 5 OH groups. You can see that 5 OH group will be there. Say for example, in the structure of glucose, you can see 5 OH group will be there. 5 OH group will be there. OH, and CH2OH. You can see 5 OH groups are there, right? So this is polyhydroxy. That is what is meant by polyhydroxy. And aldehyde means it is CHO groups. Okay. And ketone means there will be C double bond O groups. Okay. So you can, then you can choose the options. That is, the first option is hydroxyl group and COH group. There is no COH group in the carbohydrate. And CHO, aldehyde group and COH. Again, there is COH group. It is not. Then option C, ketone group and hydroxyl group. That is right. And here also, this is also possible. Hydroxy group and aldehyde group. So the correct options will be both A, C and D. Okay, both C and D. So option C, both C and D. Because in carbohydrates, you can see that, it contains aldehydes, ketones, aldehydes or ketones, and it will contain 5 OH groups. Okay, I mean polyhydroxy group, that is in glucose and fructose you can see 5 OH group will be there. So in general, carbohydrates can be defined as they are polyhydroxy aldehydes or ketones. They will contain OH groups, aldehyde groups and or ketone groups. Okay, so that's the first question. Simple question. It's a simple question from the base of the biomolecule. And second question, which of the following is an oligosaccharide? So can you please give me, Hiba, can you please give me, anyone, Dia is there? Yes. Can you please give me what is oligosaccharide? Oligosaccharide, it's a classification of biomolecules, right? Classification of carbohydrates. So carbohydrates can be classified into, yes, what are the classification of carbohydrates based on hydrolysis? They can be classified into monosaccharides, Then oligosaccharide is there, oligosaccharides will be there, and also polysaccharide will be there, polysaccharide. Okay, polysaccharides will be there. So these are the classifications of carbohydrates, right? Monosaccharide, oligosaccharide, and polysaccharide. And which of the following are oligosaccharide? What do you think? Which is oligosaccharide here? Which is oligosaccharide here? What do you think? Glucose is there, starch is there, cellulose is there, and maltose is there. What do you think? Yes, Razel, Hiba, C, option C, maltose. Is that right? What do you think? Yes, it is very right. That is, you can see that glucose, option A, glucose, that is actually monosaccharide. That is actually monosaccharide. So glucose is not an oligosaccharide. And starch is polysaccharide. This is also not oligosaccharide. Cellulose is also, it is also polysaccharide. It is not oligosaccharide. What do you mean by oligosaccharide? What do you mean by oligosaccharide? When a carbohydrates on hydrolysis, when they yield 2 to 10 monosaccharide units, right? When on hydrolysis, they will yield 2 to 10 monosaccharide units, then that kind of carbohydrates are known as oligosaccharides. Okay, so maltose is one of them, because maltose is a disaccharide and it will yield on hydrolysis, it will yield 2 monosaccharide units. So you can consider maltose as an oligosaccharide. So the correct option will be option C, maltose. Okay, very good, very good. Yes, maltose. Christopher Dean is there. Yes, very good. Megha is there. Yes. And next question, which of the following gives positive filling solution test? Yes. What do you mean by, which of the following gives positive filling solution test? And in options, you can see that carbohydrates are given, like sucrose is given, glucose is given, and also fat is there, and protein is there. What do you think? What do you think? Which will give positive filling solution test? You know, if a compound, if a compound is giving positive filling solution test, it should have free aldehyde group. Okay, free aldehyde group or free ketone group. And you can see that since, yes, what is here, which is having free aldehyde group here, which is having free aldehyde group, which is having free aldehyde group. Yes, very good. Glucose is having free aldehyde group. You can see that from the structure of glucose, it is very much clear, right? I'm not drawing the complete structure, but from the structure of glucose, it is very much clear that glucose is having free aldehyde groups. Glucose is having free aldehyde groups. Okay, you can also call it as reducing sugars, right? Reducing sugars. So you have to know what is reducing sugars. What are reducing sugars? These are carbohydrates. They will reduce tolerance reagent and Fillings reagent, and they will possess some free aldehyde groups or ketone group. Okay, and these are known as reducing sugars. So glucose is a reducing sugar, so the answer will be glucose, because since glucose is having free aldehyde group, it will give positive filling solution test. Okay, so the answer will be glucose. Option B, glucose will be the answer. Okay, yes, Hadia is there. Okay, that's it. It's a simple chapter. Okay, we can make it very easy and make it fast also, because tomorrow is your exam, right? So you will get some time for study. Okay, yes, the next question, glucose with HI to form, that is, when glucose react with hydrogen iodide, what will you get? What do you think? What will be the answer? What do you think? What will be the answer? Is it gluconic acid, or is it saccharic acid, or N-hexane, pentacetate of glucose? What do you think? N-hexane. N should be small letter, okay? N-hexane or pentacetate of glucose. What do you think? What do you think? Yes, you know that this is very important topic in this from this chapter. Very, 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 very important. Sure, 100%, almost 100% sure question. Because this question, not only this, but also the experiments we have done with glucose, which leads to the structure of glucose, that you know, right? There are four five experiments are there that we will discuss today. Okay, there are 5 experiments that we have done on glucose to find its structure. So we can directly move on to it. I'm writing the first experiment. I'm writing the first experiment, which is the reaction of glucose with HI. So I'm writing, we are going to study the experiments. You have to study the experiments. You have to know the reactions of each of the experiment. Okay, and of course we will do the structure of glucose. Yes, the first experiment. So experiment number 1. Experiment number 1. Okay. So experiment number 1 is glucose. You can see that we can write the glucose as like this: CHO, CHOH 4 times, CH2OH. Okay, this is glucose. Okay, so now we are going to study the structure of glucose. We are going to find the structure of glucose. For finding the structure, we have to do experiments. So this is experiment number 1. We have to do 5 experiments, okay? And you have to know the conclusion or inference of each experiment. What is the conclusion of experiment number 1? Then we can do it. Like, I'm taking this glucose. We know the the formula of glucose, which will be C6H12O6, right? So I'm reacting this glucose with HI, and I'm heating it. Okay, so you will get a compound like this: CH3, CH2, 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 and CH3. This will be the compound. What is this compound? What is this compound? This is 1, 2, 3, 4, 5, 6. 6 carbon atoms are there in an alkane chain, right? So this will be hexane. This will be hexane. And since it is a straight long chain, you can put it like N-hexane. So the experiment number 1, you can see when glucose, this is glucose, when glucose react with HI, they will form N-hexane. That's it. They will form N-hexane. Okay. So from this experiment, we concluded that the structure of glucose will be, yes, you can see that in glucose, there will be 6 carbon atoms. So I'm writing the structure of glucose like this. Okay, listen. I'm writing the structure like C, 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 1, 2, 3, 4, 5, and 6. Okay, so 6 carbon atoms in the glucose will be in straight chain. That is the conclusion or inference of first experiment. Okay. Then we can move on to the second experiment. What will be the second experiment? What do you think? What will be the second experiment? I'm writing the second experiment. Writing the second experiment. Okay, experiment number 2. Experiment number 2. Here we are going to react the glucose CHOH 4 times CH2OH. This is glucose. Okay, and glucose is reacting with NH2OH. What is NH2OH? What is NH2OH? What is NH2OH? It is hydroxylamine. Okay, those who are, you don't know the name, please note it. Okay, it is hydroxylamine. Hydroxylamine. So you will get a compound like this: CH, double bond NOH. Then the remaining portion will be same: CHOH 4 times, CHOH 4 times, and then CH2OH. You will get a compound which is known as oxime. So you will get an oxime of glucose. From glucose, when glucose react with the hydroxylamine, you will get oxime. Okay. One more reaction is there in experiment number 2. One more reaction is there in experiment number 2. What is that reaction? CHOH 4 times, and CH2OH. When they react with HCN, hydrogen cyanide, what will be the product? Anyone in the live? You can send it. What will be the product? What will be the product when glucose react with the hydrogen cyanide? Do you know that? Anybody from live? Do you know that? What will be the product of reaction between glucose and HCN? What will be the product? What will be the product? Yes, There is also a reaction with HCN, Hiba. There is also a reaction with HCN. Yes, cyanohydrin, very good, very good. Cyanohydrin, cyanohydrin. CH, you will get CH, CNOH, and CHOH 4 times CH2OH. This will be the reaction. That's it. So this is experiment number 2. In experiment number 2, you can see there are 2 reactions. One is glucose reacting with hydroxylamine, it will get oxime, and the second one is glucose is reacting with HCN, and you will get a compound which is known as cyanohydrin. If you don't name, please note it. Okay, cyanohydrin, cyanohydrin, cyanohydrin. Okay, cyanohydrin. And do you know what is the conclusion of this experiment? What is the conclusion or inference of this experiment? Yes, what is the inference? You know, inference is, or the conclusion is, this glucose will contain a carbonyl group. It will contain a carbonyl group. You know, carbonyl group. Just carbonyl group. Carbonyl group means C double bond O group. It may be aldehyde, it may be ketones, it may be carboxylic acid, or it may be esters. We don't know that. But the only conclusion we get from experiment number 2 is glucose will contain a carbonyl group. That's it. Okay, so that is the conclusion of experiment number 2, and we can move on to the third experiment. Okay, we can move on to the third experiment. Yeah, what will be the third experiment? Experiment number 3. Glucose is reacting with, this is very important. Okay, very important. In board exams, you can see this reaction. Glucose, CHOH 4 times CH2OH. This is glucose. This is glucose. And glucose is reacting with bromine water. Okay. What will be the product? What will be the product? Yes. You can send me the message. Okay, you can send me message. Okay. What will be the product? When glucose react with bromine water, what will be the product? What will be the product? Anyone? Anyone? Anyone from the live? No. Then we can write, don't worry. Okay. COOH, CHOH 4 times and CH2OH. Okay, CH2OH. What is this? This is gluconic acid. This is gluconic acid. Okay, this is gluconic acid. Okay, yes, yes, yes. Yes, gluconic acid. Yes. Now you are sending. Okay, yes. Gluconic acid. It is gluconic acid. So when glucose react with bromine water, you will get gluconic acid. And what is the conclusion of experiment number 3? The conclusion is glucose will contain aldehyde group. That means from the second experiment, we know that glucose is containing a carbonyl group. And from the third experiment, it is clear that that carbonyl group is actually aldehyde group. So we concluded that this is an aldehyde group. That is, glucose is containing aldehyde group. So from the 3 experiments, I draw a structure of glucose. It is not finished. Okay, it is not finished. Still, we have to fill it. Okay. So we can move on to the next experiment, which is reaction of glucose with acetic anhydride. Experiment number 4. I'm reacting this glucose CHOH 4 times CH2OH. This is glucose. Okay, glucose. I'm reacting this glucose with acetic anhydride. With acetic anhydride. Okay, with acetic anhydride. And you will get a compound like this. CHO, CH, OCOCH3 4 times and CH2 OCOCH3, which is known as glucose penta acetate. That's it. glucose pentacetate. So experiment number 4 is reaction of glucose with acetic anhydride. You will get glucose pentacetate. You know penta means it is 5, right? So what will be the conclusion of this experiment? What will be the conclusion? The conclusion is very simple. That is, the glucose will contain 5 hydroxy group. That is, it will contain 5 OH group. This was the conclusion from experiment number 4. Okay, so using this conclusion, we can fill the glucose structure like this. I'm writing OH, 5 OH here. I'm writing 5 OH in the structure of glucose. Let's see, OH, OH, okay, OH, and I'm writing OH again. Okay, here or here, OH. Okay, I filled 5 OH groups from the conclusion of experiment number 4. Okay, experiment number 4. So we almost finished it. We almost finished the structure of glucose, but before that we have to do one more experiment, which is experiment number 5. Yes, experiment number 5. What is experiment number 5? What is experiment number 5? Reaction of glucose, reaction of glucose, yes, reaction of glucose with HNO3, that is nitric acid. You know, nitric acid is a oxidizing agent. So oxidation will take place. So oxidation will take place. So what will be the product? Do you know what is the product? When glucose react with nitric acid, it will undergo oxidation and they will form a compound which is known as saccharic acid. Okay, which is known as saccharic acid. This is saccharic acid. Saccharic acid. That's it. Okay. Not only the glucose, but also if you are using gluconic acid, if you are using gluconic acid, then also you will get the same product. You will get the same product. You know, you will get saccharic acid. Okay, so in experiment number 5, you are reacting glucose with nitric acid. Okay, so when glucose react with nitric acid, oxidation will take place and they will form saccharic acid. And also gluconic acid, this is gluconic acid, okay, gluconic acid, when they react with HNO3, it will also undergo oxidation and they will form saccharic acid. That's it. Okay, so these 5 experiments are very important. You have to study these reactions. What are the products? What are the conclusions from each experiment? You have to study it, because you can expect this experiments for your board exam. It is 100% sure question. From this experiment number, from this 5 experiment, any of them can be asked. Okay, so please study it. Okay, please study it before your exam. Anyway, now we can fill it. I'm going to fill the structure of glucose. I'm filling the remaining valency. But before that, what is the conclusion of experiment number 5? What is the conclusion? From the 5 OH group, 1 OH group will be primary. 1 OH group will be primary. You can see that out of 5 OH group, 1 OH group is primary. Which is that 1 OH group? Here you can see that this OH group. If you are taking this OH group attached carbon atom, this carbon atom is attached to 2 other carbon atom. So this OH group is secondary. Since OH group attached carbon atom is attached to 2 other carbon atom, this OH group is secondary. Here also it will be secondary. Here also this is also secondary, this is also secondary. But what about this OH group? You can see when this OH group is attached to this carbon, you can see the OH group attached carbon atom is only linked with another 1 carbon atom. So this will be primary OH. This will be the primary OH. This will be the primary OH. So according to conclusion of experiment number 5, it is clear that glucose, the structure of glucose contain 1 primary OH. This is the 1 primary OH. This is that OH group which is having primary OH. Okay. So now we can fill the structure of glucose with hydrogen. I'm filling it like hydrogen here, here, here and here. Okay, so now we got open chain structure of glucose. Okay, open chain structure of glucose. And you know, for in open chain structure, you don't have to write this carbon atoms. Okay, you don't have to write this carbon atoms. You can write it like, you can write it like this. Okay, you can write it like this. Okay, so OH group is here, OH group, and OH, and below I'm writing it as CH2OH and H, and H. This will be the open chain structure of glucose, which can be named as D plus glucose. Okay, so the name of this glucose is D plus glucose. What do you mean by D? Anyone from the live? You can send me. Okay, what do you mean by D? What is this D indicating? The capital letter D. What is this D? Yes, is that dextro? Anyone from the live? Please respond. Okay, yes. What is this D indicating? Yes. Make it fast. What is that D? Is the D is dextro? That is my question. Is the D is dextro? Yes, it is not dextro. This D is not indicating dextro. This D is indicating OH group in the 5th carbon is in right side. Listen. Okay, Raisel, listen. Yes, very good. Listen, because D, this capital letter D is indicating 1, 2, 3, 4, 5. So OH group in the 5th carbon, it is in the right side. That is the D. That is indicated by D. Okay, and what is this plus? This plus is indicating dextro. Okay, the plus is indicating dextro, not the D. Okay, D is indicating the configuration of OH group in the 5th carbon, and plus is indicating the glucose is dextro. That's it. Okay, so we done the experiments of glucose for finding the structure of glucose. We done the 5 experiments and we got open chain structure. Now you can solve the questions like this question. Now it is easy. Glucose when react with HI, the first experiment, what do you get? You will get N-hexane. Finish. And what is this question? D plus glucose react with hydroxylamine, that is NH2OH. We have done it. Experiment number 2. When glucose react with hydroxylamine, what do you get? You will get an oxime, right? What is the structure of oxime from these options? What will be the structure? Option A, B, C, D. What will be the option? Is this the correct option? CH double bond NOH is there, right? But you can see 2 OH groups are in the left side. This is not the structure of glucose. Okay, this is not the structure of glucose. And here also you can see 2 OH groups are adjacent. I mean in the first and second, in the third and second and third carbon, you can see 2 OH group are nearer. This is also not the structure of glucose. This is also not the structure of glucose. And here you can see this will be the structure. In the second carbon, you can see OH in the right side. And in the third carbon, OH will be in the left side. Okay. And in the 4th carbon and 5th carbon, it will be in the right side and CH2OH. This will be the answer. So correct option will be, yes, option D. Very good. Yes, Hiba, Hadia, Brooke. Yes. Yes, there is a good question from Mohammed. Yes, Mohammed. If OH was in left side for C5, then what will it be? Very good question. Yes, I have told you that if OH group in the right side, we can put it like D, capital letter D, right? And if the OH is in the left side, we can indicate it by using capital letter L. Okay, capital letter L. That's it. Okay, that's it, Mohammed. That's it. Okay, so if the the OH in the 5th carbon, if it is in the right side, it will be D. If it in the left side, you can represent it by L. Okay, So you can see again there will be a confusion between D and L. Okay, this is not dextro and levo. This is not dextro and levo. Dextro and levo is indicated by plus and minus. You can see in the name of glucose you can see plus, that is indicating glucose is dextro. In the name of fructose you can see minus, that is indicating fructose is levo. Okay, so D, remember this point. Okay, remember this point. D and L is indicating the configuration, not dextro and levo. Okay, fine, Mohammed, understood? Okay, then we can move on to the next question. Glucose on treating with bromine water. This is also, we have done it, right? Glucose on treating with bromine water. What do you think? Glucose when treated with bromine water, it will form gluconic acid. Yes, gluconic acid. We have already discussed it. We have already discussed the reaction, right? So the answer will be gluconic acid. Simple. So once you got the 5 experiments and their reactions, it is very easy to score from the biomolecules chapter, because there will be sure 100% sure there will be question from this 5 experiment. Okay, so please study it. Okay, please study it. Then next question, glucose on reaction with HNO3. Yes, glucose on reaction with HNO3, what will be the product? What do you think? What will be the product? Yes, glucose on reaction with HNO3. You can tell me. Okay, you can tell me. I will wait. Yes, glucose on reaction with HNO3. You know that HNO3 is an oxidizing agent. So when glucose or gluconic acid react with HNO3, they will undergo oxidation. And what will be the product? What will be the product? What will be the product? Yes. Hiba, option B. Yes. Brooke, option B. Yes. Very good. Yes, we have already discussed it. This was experiment number 5. That is, when glucose react with HNO3, it will undergo oxidation and they will form saccharic acid. That's it. Simple. Okay, simple. Yes, very good. We can move on to the next question. So we finished the experiments on glucose, and we finished the open chain structure. Okay, open chain structure of glucose. And do you need the cyclic structure of glucose? Do you need the cyclic structure? I will draw it for you. Okay, if you need. Do you need cyclic structure? There is a trick for drawing cyclic structure. Don't by heart it. Okay, don't by heart the structure of glucose. I will give a trick if you want. Do you need cyclic structure and Howard structure? There are 2 more structure for glucose. Howard structure is very important for your exam. Yes. Do you need? Yes. Okay. Then I will give it. Listen. Then we can make it. Listen. I'm writing the CHO. Like this. Listen. It is not CHO. I'm writing it like C. Okay. CO and H. Okay. CO and H. Okay. CO and H. So I'm writing aldehyde as C double bond OH. And you know, one bond, consider this one bond got broken. Okay, so one bond will be open in the carbon and one bond in the oxygen. So OH group in the 5th carbon directly will attach to the 1st carbon. So you can write it like this. CH is in the left side and oxygen is there. Okay, oxygen is there. We can write it. But before that, yes, fill it. OH, and yes, that's it. Okay, and listen. Now I am going to attach the OH from the 5th carbon to the 1st carbon. So it will be like this. Okay, and you can see there will be an oxygen, right? So the oxygen I am writing it like this. I'm writing it like this. Here you can put the oxygen. Here you can put the oxygen. Yes, like this. You can put the oxygen like this. And what is remaining here? The 6th carbon, you can see CH2OH will be there. So this will be the cyclic structure. You can name it like, alpha D plus glucose, alpha D plus glucose, alpha D plus glucose, alpha D plus glucose. It is alpha D plus glucose. So now you can see there is one more term is there in the name, right? Which is alpha. What do you mean by alpha? What do you mean by alpha? What do you mean by alpha here? Alpha is again indicating the configuration of OH group. You can see this. In the first carbon, if the OH group in the right side, it is alpha. Okay. In the first carbon, if the OH group is in the right side, then the compound will be alpha. Then the compound will be alpha. If the OH group in the first carbon in the left side, then the glucose will be beta glucose. It will be beta D plus glucose. Okay, so by this way you can easily remember the cyclic structure from open chain structure. Okay, then from this cyclic structure you can easily remember the Howard structure, that is pyranose structure. Okay, that is pyranose structure. But before that we are going for a short break. We will come back soon. Don't go anywhere. We will come back soon. Okay, please wait a moment. Okay, you can take a small break. It's a small break. Okay. Okay, welcome back. Anyway, yes, I don't know is this a good news or bad news for you. Actually, I just saw a news which is in Hindustan Times that for ISC syllabus, their chemistry exam just rescheduled to March 21st. So that's why we just yes. It's just a news from the Hindustan Times. So we are doing more on it. Okay, we are doing more on it. Okay. Can you hear me? Can you hear me? Can you hear me? Yes. Okay. Yes. Anyway, back to the biomolecules. Okay, back to the biomolecules. That was for ISC syllabus. Okay, don't worry. That was for ISC syllabus. Let me check. Okay. Yes. Anyway, we done the cyclic structure. We done the cyclic structure for glucose, and then now we can move on to the Haworth structure. Yes, what will be Haworth structure? Haworth structure. How can we draw the Haworth structure? How can we draw the Haworth structure? If you want to draw the Haworth structure, then do one thing. Put a note here and pull it. I mean, put a note here and pull this cyclic structure. Pull this cyclic structure. Okay. So when you pull this, let's assume that. Let's consider you got a structure like this. Okay, you got a structure like this. When you pull this, okay, this yellow color, when you pull this, you got a structure like this. The structure is very much similar to the structure of pyran. So that's why this structure is also known as pyranose structure, because the structure is very much similar to pyran, the structure of pyran. Okay, so when you pull it, you will get a structure like this. Then how can we fill it? How can we fill OH and H here? Yes, this is each carbon. You can see this is first carbon and second carbon, third carbon, fourth carbon and fifth carbon. Okay, so how can you fill OH and H in that Haworth structure? This is Haworth structure. Haworth structure, also known as pyranose structure for glucose. So how can we fill it as, like, what is here in the right side? What is here in this right side? What is here in this right side? It is OH, OH, H, OH. Okay, OH, OH, H, OH. So what is in here in the right side? You can write it in the bottom like this. OH, yes. Then next one, again OH. The next one, it is H. And next one, the last one, it is OH, like this. Okay. So if there is OH, you can put H here. Here also H. This is H, right? So you can put OH here, like this also. Okay. So you can see this is carbon number 1, 2, 3, 4, and 5. And in the fifth carbon, you can see from the cyclic structure, from the fifth carbon, it is clear that in the fifth carbon there is hydrogen and CH2OH group. Okay, in the fifth carbon, you can see this is the fifth carbon. You can see H is there and CH2OH is there. So I'm writing like H and CH2OH here. H and CH2OH here. That's it. This is Haworth or pyranose structure of glucose. You can name it like alpha D plus glucopyranose. Glucopyranose. That's it. So this is the way of studying structure of glucose. If you want to study the structure, first of all, you need to study the experiments. From each experiment, from the conclusion of each experiment, we will draw the open chain structure. This is open chain structure. Then from open chain structure, you can draw cyclic structure. And from cyclic structure, you can draw the Haworth structure. And now we finish all the three structures of glucose. Understood? Is that okay for you? Understood? Hiba is there, Mohammed? Yes. Understood? Is that clear? Yes. Then now we can move on to the next question. We can move on to the next question. What is the next question? Number of chiral, yes, number of chiral carbons in alpha D plus glucose. Number of chiral carbons in alpha D plus glucose. Alpha D plus glucose. Number of chiral carbons in alpha D plus glucose. Okay, so what will be the number? What do you think? What do you think? What will be the number? What do you think? What will be the number? So consider, suppose if it is not alpha, it's just a D plus glucose. Okay, if just it is just D plus glucose, what will happen? This will be the structure, right? CHO, CHO, then OH, H, OH, H, OH, H, and again OH, H, and CH2 OH. This will be the structure. Okay, consider the open chain structure first. Yes, we are considering the open chain structure. If you consider this open chain structure, how many chiral carbons will be there? What do you mean by chiral carbons? What do you mean by chiral carbons? I think you have studied it in your, yes, haloalkanes and haloarenes chapter, right? Stereochemical aspects of nucleophilic substitution reaction. That was the topic. And in that topic, you have studied it, right? Chiral carbons. What do you mean by chiral carbons? Chiral carbons are carbons having 4 different groups in it. So here you can see that, yes, it's the CHO. The CHO, you can see this. I'm writing the CHO as C double bond OH. Okay. And here you can see that if there are double bond or multiple bonds in a carbon, it will not be chiral. This will not be chiral. Okay, it will not be chiral. If there are multiple bonds in a carbon, it will not be chiral. And what about this carbon? What about this carbon? You can see there will be a carbon, the second carbon, third carbon, fourth carbon, and fifth carbon, and sixth carbon. So in the second carbon, you can see what are the groups attached to it. What are the groups attached to it? You can see CHO is attached, H is attached, OH is attached, and also this much is attached, right? 4 are different groups, right? For this carbon, if you are considering this carbon, the attached 4 groups are different. So this will be a chiral carbon. So this will be a chiral carbon. Okay, similar to this carbon will also be chiral carbon, because you can see to this carbon OH is attached, H is attached, yes, and this group is attached, and also this group is attached. Okay, so listen, so this carbon will also be chiral. So this carbon is also chiral. And what about this carbon, third carbon? You can see the third carbon, it will also chiral, and this carbon is also chiral. So you can see 4 chiral carbons. And what about the last one? What about the last one? You can see in the last carbon there are 2 hydrogen groups, right? So in one carbon there are 2 same hydrogen. I mean 2 same groups are there, right? CH2 means 2 hydrogen are there in one carbon. So it will not be chiral, because if a carbon is chiral, it will contain 4 different groups, right? 4 different groups. That's it. Okay. So this is the way of finding chiral carbons. And now from this open chain structure of glucose, it is clear that it will contain 4 chiral carbons. It is clear that it will contain 4 chiral carbons. You can see that 1, 2, 3, 4. This is not chiral because it is having multiple bond. And this is not chiral. This carbon is not chiral carbon. Why it is so? You can see that it is containing 2 same groups. So it is not chiral. Okay. So that's the way of finding the answer. And we can move on to the next question. Which of the following supports cyclic structure of glucose? Which of the following supports cyclic structure of glucose? Yeah. What will be the cyclic structure? This is also a very important question that can be expected as what are the limitations of open chain structure? We have studied 3 different structures for glucose, right? Open chain, closed chain, and Haworth structure. And you know, this open chain structure has some limitations. So this question can be asked like limitations of open chain structure, or the points which are supporting the cyclic structure. So in this manner the question can be asked. So here the question is, which of the following support cyclic structure? The first point is, glucose does not form addition product with a 2,4-DNP reagent. Okay, this point could not be explained by the open chain structure. Open chain structure could not explain this point. Glucose does not form addition product with a 2,4-DNP test or 2,4-DNP reagent. And glucose does not form addition product with NHSO3. That is also right. And glucose does not form Schiff's base. That is also right. You know, the first three options are right. But the fact is, these three options could not be explained by the open chain structure. It is well explained by cyclic structure. So these are limitations of open chain structure and the points which support cyclic structure. Okay, you can consider it as limitation of open chain structure or the points which are supporting cyclic structure. One more point is actually there, you know, using open chain structure you can't write alpha glucose and beta glucose. Two forms of glucose, alpha form and beta form. That is well explained by cyclic structure, not by the open chain structure. Okay, so that is also another point of this point. The factors supporting the cyclic structure. And here in this question, it is clear that option A, B, C, both, the three options are correct. The three options are supporting the cyclic structure. So the correct answer will be option D, all of the above. All of the above. All of the above is supporting the cyclic structure. Or you can write it like, the question will be, in your board exam, the question will be like this. What are the limitations of open chain structure? So then also you can write the same points. Okay. That's it. Yes, the next question is, the non-essential amino acid among the following. The non-essential amino acid among the following. The non-essential amino acid among the following. What do you think? What is non-essential amino acid? Non-essential amino acid. Non-essential amino acid. Yes. Non-essential amino acids are amino acids that cannot be synthesized by, non-essential means that can be synthesized in our body. Okay, that can be synthesized in our body because it is non-essential. Okay, but what is essential? What is essential amino acid? What is essential amino acid? Essential amino acid is amino acids that could not or cannot be synthesized in our body. Okay, so amino acids that cannot synthesize in our body is known as essential amino acid. Since it cannot be synthesized in our body, we have to take it through diet. Okay, so that's why it is essential. That's why it is essential. Okay, and what is non-essential amino acid? What is non-essential amino acid? Non-essential amino acid means, yes, that's amino acids that can be synthesized in our body. Like, you know the examples? You know the examples? Yes, here is an example for it, which is alanine. You know, alanine, glycine, aspartic acid. These are some examples for amino acids which can be synthesized in our body. Okay, and the remaining one, lysine, valine, leucine, these are essential amino acids. So the question is the non-essential amino acid. In the following options, from the following option, option D, alanine is the non-essential amino acid since it can be synthesized in our body. Okay, so the thing you have to remember here is you have to know the examples of essential amino acids and non-essential amino acids. That's it. Okay, this is also simple. Yes, the next question is, it's about Switter ion. Which of the following compounds can form a Switter ion? Yes, what do you mean by Switter ion? What do you mean by Switter ion? Anyone know? What do you mean by Switter ion? Switter ion is actually a dipolar ion, right? Dipolar ion means it will have both positive charge and negative charge. Say, for example, I am considering the glycine. So I am drawing the structure of glycine like CH2, NH2, and COOH. This is the structure of glycine amino acid. Okay, and you can see in this structure, you can see there is amino group and carboxylic acid group. That's why it is known as amino acid, right? And here you can see that this carboxylic acid group can donate an H+. It can donate an H+. And NH2 can accept that H+. So what will happen? What will happen is CH2. This will become CH2. You like CH2 COO. Since H is donated as H+, it will have minus charge. And since H+ is added to NH2, it will become NH3 plus. Okay. So this is known as Switter ion. This is Switter ion. You can see this is a dipolar ion because both negative charge and positive charge is there, right? So what is Switter ion? In the amino acid, carboxylic acid can donate H+, and amino group can accept that H+. So they will become a compound like this. That is a compound having both plus charge and minus charge. That ion is known as Switter ion. And which of the following can form Switter ion? What do you think? Which of the following can form Switter ion? What do you think? Aspartic acid is non-essential. Okay. Yes. You know, for non-essential amino acid, glycine, alanine, aspartic acid, these are non-essential amino acid. Okay. Yes. Good. And here, yes, of course, glycine, because I have already, yes, wrote its structure. You can see that in the structure of glycine, it has both amino group and carboxylic acid group, and carboxylic acid group will donate H+, and amino group will accept that, and they will form Switter ion. So the answer will be glycine. Okay, aniline, you know the structure of aniline. You are studying organic chemistry, right? So you know the structure of aniline. In aniline, there is amino group, right? So it can accept H+, but there is no COH group. In benzoic acid, you can see there will be COH group, but there will be no NH2 group. Okay, and acetanilide, in this case also benzene ring, then it will be like benzene ring, then NH, C double bond O, CH3. This will be. Here also there is amino group. You can see that, but there is no COH group. Okay, there is no COH group at all. Okay, so only the option is glycine. Glycine can form Switter ion. That's it. Okay. Then the next one is denaturation. So what do you mean by denaturation? Denaturation is very important topic. Denaturation. Yes. When a protein is subjected to physical or chemical change, yes, the biological activity of protein will get lost. That is what is denaturation. So the protein will lose its biological activity when it is subjected to physical or chemical change. That is what is denaturation. Some examples are there, right? Like a coagulation of egg white. When you boil the egg white will get coagulated, right? Yes. So coagulation of egg white can be considered as denaturation. Curding of milk. This is also can be considered as denaturation, because in curding of milk we are adding some curd to milk, right? So there will be a chemical change in pH will be there. So it will bring some bring some energy, and that will destroy the hydrogen bond. Okay. So in coagulation of egg white also, when you boil the egg white, what will happen is the hydrogen bond in the secondary end. You know the primary protein contain primary structure, secondary structure, tertiary structure and quaternary structure. In secondary structure, there will be hydrogen bond. There will be hydrogen bond. In secondary structure, there will be hydrogen bonding. In tertiary structure, you can see there will be hydrogen bond. There will be hydrogen bond. And there will be van der Waals force, van der Waals force, van der Waals force will be there, and disulfide bond will be there. Disulfide. This is a previous year question. This is a previous year question. What are the force of attractions in the tertiary structure of protein? Okay. So what are the points? What are the force of attraction? You can see hydrogen bond is there, van der Waals force is there, disulfide bond is there, and also electrostatic force will be there. Electrostatic force will be there. So we also covered one more question, one more previous year question. This is a previous year question. Please note it. Okay. What are the force of attractions in the tertiary structure of protein? Okay, that's it. So on denaturation, when you are subjecting a physical change or a chemical change to protein, its hydrogen bond got disturbed. So it will lose its secondary and tertiary structure. On denaturation, please note it. On denaturation, the secondary and tertiary structure got destroyed. Okay. So that's why protein loses its biological activity, and that is what is known as denaturation. These are some examples for it. And now you can solve this. Now you can solve this question, right? Yes, answer is C. Hiba, Hadia is there. Answer is C, right? Yes. 1 and 2. Denaturation of protein causes loss of secondary and tertiary structure that we have already discussed. On denaturation, secondary and tertiary structure will get destroyed. So that is right. Statement 1 is right. And what about statement 2? Denaturation leads to conversion of double strand of DNA into single strand. That is also right. And third one, denaturation affects primary structure which get distorted. That is wrong. It will not affect, denaturation will not affect primary structure. Denaturation will not affect primary structure. It will affect or it will destroy only secondary and tertiary. Okay. So the correct option will be C. That is 1 and 2. 1 and 2. Yes, Humaid is there. Yes. Humaid, do you finish your revisions? Humaid. Yes. Okay. Then we can move on to the next one, secondary structure of protein. You know that secondary structure is actually indicating the shape or the pattern. That is, it contains both alpha and alpha helix and beta pleated structure. That you know. Okay, that you know. So answer will be option A, regular folding or coiling patterns of continuous portion of polypeptide chain. You know the primary, secondary, tertiary and quaternary structure, right? Primary structure is indicating it is indicating the sequence of amino acid. Yes. Humaid is finished. Yes. Sequence of amino acid. Very good, Humaid. Very good. Amino acids. Okay. And secondary structure is actually indicating the shape of polypeptide chain. If you don't know the significance of primary, secondary, tertiary and quaternary structure, please note it. Okay. Primary structure of protein is indicating the sequence of amino acid, how amino acids got linked. That is what is indicated by primary structure. And secondary structure is indicating shape of polypeptide chain, alpha helix, whether it is helical or pleated like that, shape of polypeptide chain. And tertiary is indicating the overall folding of alpha helix and beta pleated, overall folding of polypeptide chain. And quaternary structure will be the native protein. It can be known as native protein. how the protein is existing, the spatial arrangement. That is what is quaternary structure. So option A will be the answer. The secondary. For the secondary, okay. Mohammed has some questions. Sir, is it good idea to do question paper today, or should I just revise everything again? Mohammed, very good question. That is, this is your, tomorrow is your exam, right? So it will be better to do, practice questions more. Okay, do practice questions. I know that you will get some, you know the concept, and you got some classes, and you got some revision. So now you know the concepts. That's a fact. Now you know the concepts, all the concept you know. So it will be better to practice questions more than revising the theory. It will be better to practice questions, especially from previous year questions. Okay. Good question, Mohammed. Yes. The next one is, which of the following structures represent peptide chain? Peptide chain. In the biomolecules, you have to study 4 biomolecules. That is, it is not 4, it's 5. 5 biomolecules you have to study. That is carbohydrates. Yes, first one is carbohydrate. Second one is protein. These are very important. Okay. These are the more weightage. These are having more weightage. Carbohydrates and protein. And after that, there will be vitamins, enzymes, and nucleic acids. Okay. So, in carbohydrates, I'm writing generally, in carbohydrates, and in protein, and in nucleic acids, you can see there will be some bond between, linking the symbol units. In carbohydrates, there is a bond which is linking the monosaccharide units, which is known as, do you know that? In carbohydrates, which is the linking bond between the monosaccharides? It is known as glycosidic linkage. Glycosidic linkage. That's it. Glycosidic linkage. And in protein, it will be peptide bond. You can expect some questions from the bond. Okay, the bonds in these 3 biomolecules. And in nucleic acid, the bond will be phosphodiester linkage. Phosphodiester linkage. Okay, phosphodiester linkage. That's it. Phosphodiester linkage. It will be phosphodiester linkage. So in carbohydrate, it is glycosidic linkage, and protein, it will be peptide bond, and in nucleic acid, the linkage will be phosphodiester linkage. So here, which of the following structure represent peptide chain? That is, you have to identify, is there any peptide bond or not? So how can we identify peptide bond? What is peptide bond? You can see, I'm writing an example for it. Glycine is CH2 COOH NH2, right? And I'm writing another amino acid which is alanine. It will be CH COOH NH2 and CH3. This is alanine. Okay. So when they combine, you can see that these are 2 amino acids. So how they combine, how they form peptide bond, that we can study like this. From the COH group of one amino acid, the OH group, and the H from the other amino acid, they will combine. When H and OH combine, they will remove H2O. So what will be the bond here? The final bond will be like this: NH2, CH2, CO, then CO. Then what is remaining here? NH, CH, COOH. That's it. So here you can see that. Yes, here you can see that there is a CONH bond. That CONH bond is known as peptide bond or peptide linkage. That's it. Peptide bond or peptide linkage. Yes, yes. Is that option A or C? Is that option A or C? What do you think? In option A, please check it. In option A, you can see a CONH bond. You can see a CONH bond. But is that an amino acid? You can see. Is that an amino acid? What do you think? And here also, CONH is there and there is no CO bond. So this is not. Option B is not a peptide linkage. That you can understand. Okay. And here you can see there is also CONH bond. CONH bond will be there. CONH bond will be there. Okay. But remember, you can see this can be considered as an amino acid. If you are considering this as amino acid, this will be another amino acid, right? This will be another amino acid. This will be another amino acid. And in option D, what about option D? What about option D? What about option D? Yes, CONH is there. CONH is again, it is there. Okay, so is that option A or C? What do you think? Is that option A or C? What do you think? In A, you can see that CONH and here CO, nearer to CO there is NH group. Okay, so CO and NH, you can see that in between CO and NH there is no carbon, but here you can see some carbon. Okay, and here also you can see two NH is there. There is no CONH bond in here. So this is A is not the correct answer. And what do you think? Is that option C or D? What do you think? Is that option C or D? You can see this is a amino acid and this is another amino acid and this is another amino acid. Okay, so is that option A or C? What do you think? What do you think? Is that option A or C? So do one thing. You can try each of this. I mean, take each amino acid groups and try it again. Okay, take each amino acid groups. Identify. First you have to identify each amino group, each amino acid group. Okay, then try it again. Okay, take each amino group and try it again. Yes. Now you are telling the right answer. Yes. So do it. Okay, do it. So try yourself this question. Try yourself. You can try it. Okay, try it. And one more thing is there. In nucleic acid, the nucleotides are joined together through phosphodiester linkage, hydrogen bonding, glycoside linkage and peptide linkage. Now it is clear, right? You can see that in nucleic acids, the linkage will be phosphodiester linkage. In nucleic acid, the linkage will be phosphodiester linkage. And do you want to know the phosphodiester linkage? Listen here. Let's consider, the nucleic acid, each nucleic acid, say suppose if it is DNA or RNA, it will contain a pentose sugar. Consider this as pentose sugar. It is not finished, it is not the complete structure, but consider this as pentose sugar. Okay, consider this as pentose sugar. So I'm writing the structure of pentose sugar, and for DNA the pentose sugar will be deoxyribose, and for RNA the pentose sugar will be ribose. Okay, and here when this pentose sugar is attached to a nitrogen base, okay, when a pentose sugar is attached to a nitrogen base, then it is known as nucleoside. Okay, then it is known as nucleoside. So I'm taking two nucleosides here also, one more nucleoside. Okay, nitrogen base will be there, nitrogen base will be there. Okay, nitrogen base will be there. So when a pentose sugar is attached to a nitrogen base, you can take it as, yes, you can take it as nucleoside. Okay, nucleoside. And then I'm taking a phosphate group. Listen, P O H double bond O and O minus. This is phosphate group. Okay, phosphate group. And you can see in from each pentose sugar there will be CH2OH. There will be CH2OH will be there. CH2OH will be there. Okay, CH2OH will be there. And here also, listen. Here also CH2OH will be there. Here also there will be CH2OH, and here also there will be CH2OH. So what will happen is, when they react, what will happen is, listen here, this H and OH, they will combine to form H2O. Here also H and OH, they will combine to form H2O. So when they combine, when two nucleosides combine, they will donate, or they will release 2 molecules of H2O. They will release 2 molecules of H2O. Okay, so what will be the final product? What will be the final product? Yes, it will be like this. It will be like this. The final product will be like this. The final product will be like this. Listen here. The final product will be like this. PO is there. PO is there. Here also PO is there, and it is attached to CH2OH. CH2. And here also OH is combined with oxygen. Okay, and here you can see that there is a diester linkage. Here you can see this. This is a diester linkage. And here also there is diester linkage. So this is phosphoester linkage. Here also you can see phosphoester linkage is there. So there are 2 phosphoester linkage between, you can see that 2 oxygen is bonded with the carbon and phosphorus, right? This oxygen is bonded with phosphorus and carbon, and this oxygen is also bonded with the phosphorus and carbon. So this is one ester and this is another ester, that is phosphoester. So there are 2 phosphoester, so you can call this bond as phosphodiester linkage. That's it, simple. Okay, we don't have enough time, that's why I'm making it fast. Okay, so if you have any doubts, you can ask. Okay, anyway, this is the questions from biomolecules. You can solve it by yourself, right? This DNA complementary bases, you know the nitrogen bases in DNA and RNA, right? In nitrogen bases, it will be adenine, cytosine, guanine and thymine will be there, and adenine and thymine will be the complementary nitrogen bases. They will make hydrogen bond between them. And guanine and cytosine, they are complementary to each other. They will form some hydrogen bond between them. So that's it. That's the answer. Adenine and thymine, guanine and cytosine. So answers, option C will be the answer. You can do it by yourself, right? That's it. Okay. So these are the questions. I mean, some important questions from biomolecules. You can also study the questions. We don't have enough time, so I'm concluding it, because you can also study the questions from vitamins. Okay, vitamins, the classification of vitamins is there, and vitamins and their deficiency syndrome will be there. So you can study it. And these are the topics that you have to remember for your board exams from the biomolecules chapter. So we have covered all the 10 chapters in this live session. So I think it will be very helpful. Hope you enjoyed it, and hope it will help you in your board exams. Okay, but before leaving, please wait a moment. Okay. Okay, so there is another good news for you, because at 2:30, at 2:30 there will be my sir is having a session, live session for you guys, because he's doing the whole 10 chapters. He's doing a live session on whole 10 chapters, so it will be helpful very much. It will be very much helpful for you, so try to attend it. So anyway, all the best for you. Okay, in case of any doubts, you can ask me anytime, and hope you guys are enjoying it, and you can put it in the comment section also. And don't worry, and don't forget about the live session at 2:30. Okay, my sir will be dealing it, so it will be very helpful for you. Anyway, all the best, guys. Thank you so much for attending me. Okay, thank you.